I know. I forgot it. I'm very sorry. Oh, wait. I'm going to type. We'll see. All right, so XC right here, and we're going to store that. I'm going to store that as A. And if this is free response on the AP exam, I can now say let. Oh, I don't know. That's something different. Hold on. I'm just going to have to do my intersection again. I really didn't know.
Did you leave your pointer at 1?
I probably,
Because I remember seeing that on your calculator.
where I restarted this, it probably.
Oh, yeah. Now it's saying X of C is
Yeah. Okay, so whenever you get your intersection here, I've got 0.403813. You definitely do not want to round that number off. It is better if you store it in your calculator. So I'm going to go back to the main screen, just hit home, and if you type the letter X and the letter C, it should be 0.403813.
Yes.
You may have done the other intersection first. Oh, you got 0.54? I do not know. Check your y equals and make sure your equations are incorrect. Okay, quiet please. Okay. All right, so if you type in XC, just the letter X and the letter C, and you hit enter, it should bring up whatever you just got for your intersection there. So I'm going to store this as the letter A. The reason I can't just leave it being XC is because when I start to find that other intersection, it's not going to save it. And so if, on free response questions, I would suggest that you do this. I'm going to say let A equal 0.403813. You're going to type XC, so just type, okay, and hit enter so that it has that number on the line. And then once you have done that, you're going to hit the store button. STO? Yep. And then tell it alpha, whatever letter you want to use. I used A here. Yeah, you have to actually find the intersection. Where's your little spider at? It's over on this side, or it's over here. STO is the button right above on. Apparently not. Yeah, it is helpful. So what you got?
In the segment, I got it. Let's go. That's just that.
I think it's probably okay. No, I can't know for sure till I figure it out. All right, all right, quiet. We're going to find the second intersection. All right, let's make sure I've got my. Look at your y equals and make sure these equations are correct. I think mine are incorrectly. If you messed up, it's probably in that second one, I would guess.
You put the sign, you put the one inside.
Yeah, one should be on the outside. So if your one is not on the outside of that parentheses, then it's going to give you the wrong intersection points. Never noticed he does have kind of strange colored eyes. They're greenish, bluish, grayish. Alright. I didn't mean strange in a bad way, just uncommon. Let's say that. Alright. Okay. Okay. Alright. Intersection. We're going to find the second one. On the lower bound, you need to be somewhere on the left-hand side. And then, first curve, it doesn't matter. If you just hit enter, enter for those that should do that correctly. Okay, so the second intersection that I'm getting is 5.45123.
I think it should be 1, 2, 3, 4, 5 after the 1, 2, 3.
Okay, so I'm going to also say I'm going to use a B for this one, equal 5.45123. Alright, so I'm going to go back to the main screen and I'm going to store that one. So this time when I type XC and hit enter, I'll get this number. And then store alpha B. And you can use whatever letter you would like. Don't use X. But any other letter is fine there. Don't use Y. Yeah, do not store anything as X ever on these calculators because it will cause you great pain and anguish. Alright, so, alright. It erases whatever was there, yes. Okay. Alright. Alright. Okay. Alright, so let's go back and look at this graph for a second. So we're talking about this area here. Does it let me screenshot this? Yes. Alright, so you guys can't do that, but for me to.
No, I actually can't.
Alright, so on this graph, we're going to have cross sections that are squares perpendicular to the x-axis. So our cross section is going to have a square perpendicular to the x-axis. So those of you that were out on Friday, to give you an idea of what that is going to look like. Okay, so this here has a base that is just a circle, right? So if I took at every little slice, like you can see this sort of medium colored wood here, if I take a cross section right here, all of the cross sections of this figure are all squares. So it's like you're taking each little piece right here and you're building a square off of that. So like on this end, yeah, this end you've got like a little tiny square and then bigger squares, and then you've got that square and then the bigger square. At the highest point you would have your biggest square, and then they'll go back down smaller. Like on this, you would probably have your biggest square somewhere about right here, wherever that is furthest apart, there. So this one would have, this shape right here would be the base. So like if you were looking at the bottom, if we made one for this and you were looking at the bottom, it would be that shape on the bottom. Yeah. It would be flat, but on the top it would be, yeah, it would not be flat on the top. Well, so it would be flat, but it would look like that shape. So it would be like curved weird on the sides, but it would still be flat. It would be like 3D curved. Yeah, that's your base. Yeah, so like if we were looking at it from a bird's eye view or from the bottom, either one, that would be the base. Okay, and so we are taking little squares, and I'm not sure if he's being serious about
No,
this.
I'm being actually. I looked at it and I tried to redraw it and I couldn't.
Yeah, so like the idea is like you would, like we've actually done, we might do this project again after the AP exam this time. But like you take like a little slice right here, and let's say that has a length of 1. Then you would make a little square right there that has a length of 1. Then you move over a little bit, and you make another square. This one's going to be a little bit bigger than the one before. And then you'd have here, and you'd have another square, but they're going to all start running together and look crazy. There. Trying to. Yeah, I'm trying to. It would be perpendicular to the base there. So what but the bottom of the square is going to be, you know, this vertical piece right here because it's perpendicular to the x-axis. So I'm going to call that little sliver right there, just right here. So like we're going to try to make a square right here. So that base of that square is right here, and I'm going to call it S for like the length of the side there. So if I want to figure out S, now keep in mind S doesn't have to be right there at that point. S could be anywhere. It's any of those vertical slices, right? So we're not going to integrate yet for S. If I want to know that side right there, I would just have to take top function minus bottom function, right? Which one is the top function here? F. So I would say f of x minus g of x. So that would be just the length of this side right here. The next thing I want to think about is what the area of this square would be. My cross-section square, what I've tried to draw here, sort of a 3D figure. This is like, it's a square. So both sides are the same. So if this side is S, this side would be S, right? So the area of the square would be, not 2S, S squared. So we'd have f of x minus g of x squared. Because we do S times S or S squared to find that area. So what we need to do now is we need to find all of the squares between 0.403813 and 5.54123. So to accumulate all of those, to add all of those squares together, we can use an integral. So you're going to find the area of you get the formula for the area of your cross-section here, and then you integrate that. If you're in terms of x, which we are here, because if our squares are perpendicular to the x-axis, that tells me we're doing a dx problem. We'll take the derivative with respect to x. So we will integrate from our x-coordinate here, which is a, to our x-coordinate here, which is b. And see, if this is a free response question, because you have said that a equals this number and b equals this other number, you can just write A and B now, and the graders will assume you're using those numbers, so you don't have to write those decimals out every time. It'll keep you from making a copy and error a lot of times. And so we would be integrating f of x minus g of x squared. You need to write down what you are putting into the calculator. So, yes, we do not have to solve this by hand, but this needs to be written down. And from there, we can integrate with the calculator.
But it doesn't do like calculator notation, so you can't really just y1.
Right. Don't use y1 minus y2. Use whatever they have called them here.
So if it's interactive, you can just say A to B, f of x minus g of x.
Yes.
I'm trying to use y1.
Do be really careful right here and make sure you've got your parentheses right. You may want to use a bracket instead of that second parentheses, because if you don't put that second parentheses and put a square here, you would lose a point on this, because you would really mean f of x minus g of x squared, and g of x would be the only one squared. So you have to be really careful with your notation when you're writing that down. You guys see what I'm saying? Like if I did f of x minus g of x squared like that, that would not be correct, because you'd be missing those parentheses that group f of x minus g of x together. So let's hope it works on the calculator without breaking it. All right. It's probably going to take a little while. F3, integrate y1 of x minus y2 of x. I got to close the parentheses, so you should have an extra set of parentheses around the y1, y2. I'm going to square it, comma x, comma a, comma b.
I have the habit of putting too many parentheses.
And it's probably going to be a tough one for the calculator. It's a very tough one from the calculator. I hope we'll do it. Yeah.
Just give it a little tap. It worked with Jack.
When my dad was first, when my dad was first learning how to use the computer, he would tell you that if you do your mouse like this, it helps it get faster. You guys don't know about waiting on the internet like I did, though.
I know we do. In 7th grade, we had the Acers.
They were pretty bad, but not dial-up internet bad. You guys don't know about dial-up internet bad.
I've heard stories of dial-up.
The Acers were pretty bad.
That's like my mom telling me that flashing your lights at a red light makes the change.
If you rub the dash, you're good.
If you rub the dash,
Yeah, you distract your mind with anything, it'll go by faster.
Yeah.
This is your volume. So this particular problem didn't give us units, but whatever the units are, it would be this many units cubed.
So the enclosed area is a base of a shape. Take infinite little squares.
Yes.
Effectively makes like this whatever shape it is.
And this is the volume of said solid.
Make it like a smooth.
Yes. Yep. So it would be like, you could think of these as like separate squares, but if you have infinite, then it'd be completely smooth. Yeah. Now, some of my projects up here, yeah, those are cross-section projects, which we cut like each little piece out, so they're not entirely smooth because they're showing cross-sections that aren't infinite there. They have width to them. But you can imagine what it would look like if it were completely smooth with those. Yes.
No, I got a positive.
All right, do you have y1 and y2 in the where your B and A's were backwards? So if your B and A are switched from what mine should be, they were, and so that's making your limits backwards, which is giving you that negative. There.
So, like, if you ever get a negative, just most of the time it's a positive. Like, there's
well,
no way to get a negative.
if you do, yeah, you should never get a negative on these problems. So volume should always be positive. So if you get a negative, you've done something wrong. And like in your case, you just need to use the positive instead. But there are some things you could probably do wrong that would give you a negative, where it would, like the positive would not be the correct answer.
I was listening to Calc.
Okay. All right, questions so far? I know some of you who were not here on Friday may have many. Yes. Yeah, so if you have cross sections perpendicular to the y-axis, your equations have to be in terms of they have to be in terms of y, so they have to be solved for x. So they really can't. So like in this case, everything was in terms of x. Our equations were solved for y, so that they had x's in the equations. So we didn't have to deal with that. We can look at somewhere you have to pay attention to that. Okay. Oh. It does sound like Laura's not paying attention. I love Austin Coley, but I do not want to see him right now.
Crack me up, thank you for that.
Okay. Let me pull up the key for.
Yeah, give Laura a harder one.
That's funny.
Okay. Let me tell you the answers to these. If you were not here and still have to do this, you're welcome to make a note of them, but please have some work with them. Just circle and we'll not get you. All right. All right. One is C.
Oh, I gotta check my guessing. No, sorry, I promise you I'm wrong, I'm guessing. What was the first one?
C. Okay. 2 is B.
And like guessing.
3 is D.
I was kidding. I watched him do it.
Yeah, we watched him. Yes.
No, stop mocking.
And 4 is D.
Doesn't matter.
Yes.
No way.
All right, quiet because I cannot hear Laura. You guys have talked the whole time today. So. That's like 1/3 x. So it's just you're gonna divide by 2. Yeah. Okay. Okay. All right. So no, because 5, 6, and 7 are homework for tonight. So you're gonna have to actually do those, Thomas.
Yeah, I can do it. But I've heard guess on it. I just want to see.
All right. So
Write down the 100%.
so let's just go through the setup for each one. Okay, I'm not going to solve each one. Well, it was only number 1 that you had to solve by hand, right? Yeah, the rest of them were calculator active. But let's look at the setup for each one. So for this one, you have a base of a solid is the region in the first quadrant, bounded by the graph of this and the y-axis. So y equals 1 minus x over 3 is like y equals 1/3 x. So if you graph that, because this was not calculator active, you have a y-intercept at 1, and then your slope is down 1 to the right, 1, 2, 3. So you would just have a line that looks like this here. And so we're looking at the base being, alright, so we're looking at this area right here as our base. And we want cross sections perpendicular to the x-axis. So perpendicular x-axis means we'll be taking a slice, something like this. And then from that slice, we will be drawing a square there. So I'm going to call this side right here S, for the side of my square. And S is just going to be top equation minus bottom equation, but the bottom here is just 0 because that has, it hits the x-axis there. So S is just 1 minus 1/3 x, or x over 3. There. Okay, so the area equation, the area of this square that I'm building right here would be S times S, right, because it's a square. So it'd be 1 minus 1/3 x squared. And if we want to find the volume of this, we would need to integrate. What limit should I put on the integral? 0 to 3. Yeah. You're looking at your x-axis because this is a dx problem. So that area of the base, the lowest x-coordinate would be right here at 0. And then it goes all the way up here to 3. I mean, I'm just thinking about the graph is what I was looking at here. But you could set it equal to 0. You could set equal to 0 and solve. That would work also. They can be in other quadrants. They are often in the first quadrant just because they can get a little complicated if they're not, but they can be in other quadrants. Okay, so I'm not going to go through and solve that. You would need to square that out and get 1 minus 2/3 x plus 1/9 x squared. Square, double square, and integrate and plug in your numbers. It's not too bad, but I don't want to spend too much time on that part because the setup is what's really, really important here. Mm-hmm. Yeah, so I was just looking at the graph to figure out what this point right here was, where we hit the x-axis, but you could do 1 minus 1/3 x equals 0 to see where that's at as well. So 1 would equal 1/3 x. You can multiply both sides by 3, and you'll just get 3 for your x to find out where that x-intercept is. Right, right. So like right here, we don't have a top equation minus, well, we could have a top equation. We could write it like this, 1 minus 1/3 x minus the bottom equation, since this is in the first quadrant, it's just 0 there, so it just ends up being 1 minus 1/3 x. Okay, questions? You'd integrate first and then plug in your 0 and 3. Yeah. Yes. Well, we're going to look at least the setup on all these. All right, let's go to number 2. Okay, this one's going to be different because we're perpendicular to the y-axis. Okay, so whenever we're talking about ones where we're perpendicular to the y-axis, our cross-section is horizontal. Okay, so it's like we've got this piece right here and we're building, oh gosh, it's a very bad square. Let's see. I mean, our base does look kind of like a banana, a little bit. All right, so I'm going to call this part right here in the base here, I'm going to call that S again. This is S. So whenever we're dealing with the horizontal slice here, we need to do the right equation minus the left, but we need them to be in terms of y. So this equation on the right is y equals x to the third. They did not give it to us in terms of y. How would I find it? Yes. Yeah, you can still do right minus left. Because what'll happen is it will be. You could probably do either one because when you square it, it's not going to matter. But right versus left is what I would stick with, because what happens is you end up with negative values, and by doing the right value is actually like the smaller value, but whenever you subtract the left, it has like a minus, a negative effect, which will give you a positive here. For area, it ends up being squared most of the time, which means it's not going to matter if you had them backwards. As when you square that negative value, it becomes positive. But if we're just finding like the area, let's say the area was over here, then you still want to do right minus left, even though it seems like you should do left minus right there, because it's like furthest away, it's the closest, but do right minus left. So we would cube root both sides here, and so x would equal the cube root of y. That's this equation right here. And then our other equation, this line right here, we've got y equals 4x. So we could divide by 4. And so we would have x equals, you can do y over 4, or I'm going to do 1/4 y. So let's start with just s. That's right minus left. That's the cube root of y minus 1/4 y. Then I need a square. So for my area, I would just be taking the side and squaring it, right? So I'm going to have the cube root of y minus 1/4 y. I'm going to put parentheses around that and square it.
Would it be correct to just put S squared?
It is probably okay to do that, because as long as you have written S equals there, it would probably be okay to do that as long as you've written S equals. And then we would integrate here, and we're integrating the cube root of y minus 1/4 y squared dy. What limits should I use on my, what? Not 0 to 2. 0 to 8, because whenever you're doing this with terms of y, when you see that dy right there, you have to look at the y-axis. So 0 to 8 here. And so again, I'm not going to solve that, but whenever you do it, you should get, yes, this one, 2, 3, and 4 are calculator active. You could do it by hand. It would just take a long time to do it. I mean, and you wouldn't get those decimal answers, so you'd have to use a calculator at the end. got to keep in mind, though, this is 3D. You're not seeing the whole picture.
Well, I got two. Well,
I just can't think which one the grader would choose to be right. I go with that one.
That's a good strategy. Couldn't be anything
The
but.
problem is probably computer did. Not for the lesson, I got 100%. It saved me time.
Okay. All right. This time we're again perpendicular to the y-axis. And this time we have a little bit different situation for our cross section. So this time we're perpendicular to the y-axis, and each cross section perpendicular to the y-axis is a rectangle whose height is 5 times its width in the xy plane.
I don't like these.
So it's a pretty simple graph right here. It is calculator active, but I'm still going to just graph this one by hand because it's just a line. So, and it's got a y-intercept at 2 and a slope of negative 2/3. So you're going to get just this graph right here. Okay, so what we have to be careful about is we're taking a horizontal slice. We're perpendicular to the y-axis. Be really careful. Every once in a while you will see a problem that says parallel to the y-axis.
That's funny, man.
That would be the same as saying perpendicular to the x-axis. So be careful. I feel like it's cruel whenever they do that.
That's fine.
Yeah.
So they said it was parallel to the x-axis. Perpendicular to y.
Yes. So, but perpendicular to the y is the one that's going to tell you it's dy. So if they say parallel, switch it to which one would be perpendicular to think about. All right, so I'm going to call this right here S. We would do right minus left, but we need to be in terms of y because we're doing this in terms of y. So we got y equals 2 minus 2/3 x. We would need to solve that for x. So we'd get y minus 2 equals negative 2/3 x. We would divide by negative 2/3, which is going to be the same as multiplying by negative 3/2. And so we would get negative 3/2 y plus 3 would be our x. Oh, and tennis, I guess it is time for you guys to go. The homework is going to be the last 3 questions from that worksheet, so you don't need any other sheet. I do need to give you guys I'm already recording, so fast forward through the first part of this. It's a similar idea. Let's see how Jack does after 2 days. And down here, down over here.
I like that. Yeah, that's the worst. It's the worst thing.
All right, so we need to use negative 3/2 y plus 3 instead of the equation as they give us here. So it would be negative 3/2 y plus 3 minus, this is just 0 right here because it goes all the way to that y-axis. So we could put minus 0 here if we want, but we don't have to. Let's finish up this one. Oh. What interview are you? Oh, good. Good luck. All right.
I guess more than just, like, I'd go if it was a $1 interview.
Listen, I'm going to tell y'all, I'm pausing this. Even though Chandler, I'm upset with you too. Even though you have.
I know, but guess what? Actually, just leave my keys on the
In the car.
Leave them in the car. Leave them in the gas.
Leave it unlocked. No, just put my keys like on the deck. Just put them somewhere. Put them somewhere and text me where they're at.
Front seat. I know, so we can find them.
No, listen to this. Put them somewhere and text me where they're at.
Put them in the trash. Put them in the front seat.
You'll have to.
Thomas's car is going to be stolen after class today. All
It
right.
would not be a long investment to steal.
It would be better to spend your time filling out the $500 scholarship application. They can't bring it back. All right. And all those little tiny ones are ones that somebody at Elkin is going to get. They're not national scholarships. They're ones that somebody at Elkin, most of them anyway, are ones that somebody at Elkin is going to get. So go apply for those little tiny ones. A lot of them can be used even if you're going to Surrey.
No, there's a lot.
Yeah, some may not be, but
There's a lot that I can't.
yeah.
Like literally 3 quarters of my family.
Yeah, there are several that you have to be the daughter or son or daughter of a something or another. Yeah, like there's some that have limitations, but
It's okay. I got my green card. My mom called me today. She was like, "Are you okay?" I'm like, "Yeah." She was like, "Oh, I just saw a whole bunch of cars go towards school."
Okay. All right. So our area here, your rectangle has a height that is 5 times the width in the xy plane. I've called that width in the xy plane S. So the height of this rectangle would be 5 times S. So for my area, that would be 5S times S, which would be 5S squared, which when I plug in S, it's going to be negative 3/2 y plus 3 squared. And so we would integrate this 5 negative 3/2 y plus 3 squared. And we're going to integrate that. What are our limits?
0 to 3.
Not 0 to 3. 0 to 2. Look at that y-axis. And we're running out of time quickly, so I'm not going to do number 4. But I'm hoping that this helped you, specifically with those ones where you got to change them to y's. I think are a little tricky.
Thanks. It will be
Yes. Let me just get it tomorrow. All right.
I would love to study abroad.
Study abroad is
They literally gonna be in the computer all day. What are you gonna study abroad?
yours wouldn't be that helpful to study abroad.
You can hang out with Bruce's family. Yeah.
Okay. All right.
I went to Equilateral. I basically was. That's 90% of the student population.
Oh, you know what Rosanna told me? She was like, "Yeah, I don't understand 89% of professors. They're Indian and they have like a heavy accent. So like in her business class, she just like doesn't know what he's saying." And she just like
Tends to happen.
There's a lot of
That happens a lot in STEM.
And yeah. And I did not have that experience because Meredith is a really small school, and most teachers there are there to teach, not to do research. But at larger schools, they're often there to do research. Let's see. Wonder who? Oh, that's Chandler's. Hand that back there to Margaret. She's gonna convey that to. Okay, so to get an idea, today we're going to be talking about triangles and semicircles. So if we're looking at this picture here, if I had, well, they don't have semicircle as an option. They do a whole circle, but you guys get the picture right here. It's just the top part of this, half of a circle. Well, they kind of have this part down here below, like it. Theirs is going all the way through, but the colored in part here is what we're looking at. So if they show the slices here, it would just be this top part for semicircles. So you'd have something that would look like that.
It looks like that thing from Australia.
Yeah. All right. All right. Then we've got two different types of triangles that we can have. We can have an equilateral triangle here, which would look like this.
Also really cool looking.
I like that. It's pretty cool. Or we could have a right triangle with the leg in the triangle, so it's sort of like to the side here. So your base and your height here are perpendicular to each other. And that would look like this. It's similar, but it's like you take that one we just had and put it over to the
It
side.
looks like in Finding Nemo, whenever they go to Sydney, Australia.
Mhm.
It's like a thing kind of like
Can we watch that clip real quick?
We're not because we don't have time. But I do know what you're talking about, and I need to see if that is like related.
That's how I remember it.
Yeah. So these are the type of cross sections we'll be looking at today. So, all right. So a solid has a base that is bounded by the curves y equals x squared and y equals 2 minus x squared in the xy plane. Cross sections through the solid perpendicular to the base are parallel to the y-axis. Watch out for that right there. I said it was going to happen. Parallel to the y-axis. Is that dx or dy?
That's DX.
It's dx. And they are semicircular discs. So,
It doesn't specify which quadrant it's in, so we assume that it's Q1.
do not assume it's in Q1.
I just assume Q1.
This one is actually going to be in first and second quadrants. So if we graph, no, the cross section can be a semicircle either way. Yeah, the cross section can be a semicircle either way. But since they don't tell you first quadrant, you want to just think about this graph here. So if I graph 2 minus x squared, it's going to be upside down, and it's going to look like this. And if I graph y equals x squared, it will look like this. And you'll have those intersection points right there at 1, 1 and at negative 1, 1. So we're looking at this area right here is our base. Okay. All right. Okay. All right. So we are going to have cross sections that are parallel to the y-axis. So if we think of drawing that in, something like this, and we'll just put this little slice right here. And so we are going to, you like parallel better than perpendicular? Yeah, you see perpendicular more often. Yeah. All right. So what we're going to be doing here is we're going to be making a little semicircle here. So I'm actually going to think for a second about the area of that semicircle. So the area of a semicircle is going to be 1/2 times pi r squared. Here's what makes this so tricky and causes a lot of students to miss this. Radius. Is the radius top minus bottom here? No. Radius is half of that. So when we're looking at a radius here of that semicircle, that radius is going to have to be the top equation minus the bottom equation divided by 2. So I'm going to write that down here. My top equation is 2 minus x squared minus the bottom equation, which is just x squared, and I'm dividing all of that by 2. Blue is the 2 minus x squared. Red is just the x squared.
And we know it's top based on like it's their peaks.
Yeah, you're only looking at this like yellow section right here.
So
in that section,
okay, my bad.
the blue one is on top. It will probably switch in other places, but we only care about the part that is our base. All right, so if I simplify this, I've got 2 minus x squared over 2. So that is 2 minus 2x squared divided by 2, which is going to give us 1 minus x squared. So that is our radius. What most students do wrong is they forget to divide that by 2. Because you don't do that for squares or rectangles. You're just going to use that part that we were calling S on the other problems. So that radius is 1 minus x squared. So our area formula will be 1/2 pi times 1 minus x squared squared. Okay, questions so far? All right, we are going to integrate this. So we've got 1/2. Correct. And so that would be -1 to +1 here. And for the sake of time, we are going to do this on our calculator. And we're going to do all of them on the calculator today. This they might give to you without a calculator, but we just don't have time. So we type that in. Let's make sure I've got everything in the right place. We're getting 8 pi over 15. Which will be our answer here. What's that, Thomas? Since I got a pretty simple answer, I think I'm just going to leave it. But you could hit the green button and enter on this. This is one that would probably not be calculator active on the real test. We're just cheating a little bit. Another little note, if you are doing this by hand, this 1/2 pi, you can leave it in here or you can pull it out front as the coefficient, which will make it a little easier when you're integrating. So if you pull it out, no, it's still just the same. It would just be like this 1/2 pi integral from -1 to 1 of 1 minus x squared dx. Now, nothing changes when you do that. But it will make it a little easier to integrate because you won't have that 1/2 pi on the inside to deal with. Just leave it out front and multiply by your answer. You can never ignore the integrate. Oh, this is just a coefficient. It's just a number that you're pulling out. if you have a coefficient ever, you can pull it on the outside.
So if that
Yeah.
pi was like a 3,
Yeah, as long as it doesn't have a variable with it. And pi is not a variable, pi is a number, so it's okay. So as long as it doesn't have an x with it, you can pull it out. And as long, like if it's got to be multiplied, it couldn't be like 1/2 pi plus something. Okay. All right, let's look at the next one. Volume of a solid whose base is the region bounded by the lines of 1 over x minus, or 1 minus x over 2, and g of x equals -1 plus x over 2, and x equals 0. The cross sections are perpendicular to the x-axis, and they are equilateral triangles. So before we even start with the graph, I need us to think about equilateral triangles. So what we're going to end up with here is we're going to have a graph, we're going to have an equilateral triangle, and we're going to know some expression that will be this bottom side of that triangle. We'll call it S, like our square, right? That left minus right, or top minus bottom in this case, top minus bottom for this one, is going to give us whatever our S is. Okay? Now, can we find the area of this triangle knowing S? We can, but is it going to be easy? It's not going to be easy. So, if we think what we need is whatever this is right here, I'm going to call it H for now. We need to have H so that we can do 1/2. Our area is going to equal 1/2 S times H. But we're not going to be able to solve this with throwing an extra H in there. That's not going to work. So we need to figure out what H would be. Okay. So what are all the angles of an equilateral triangle? They are 60. So this is 60 degrees right here. This one right here would be 60 degrees. This top one's right here. This would be a 60-degree angle that would be split in half. So it'd be 30 and 30. Which gives us one of those special right triangles. So 30, 60, 90. So if you know the short leg, this is 2 times the short leg, and this is the square root of 3 times the short leg. You could also set up trig, but it'd have to be calculator active for you to do that. Yes. The x is, I should write it x squared of 3. The x is not underneath the square root. 90 is right here. And then the 60 would be across from the longer leg. Okay? So, what you really need to know for a 30, 60, 90 triangle is this shorter leg. What could we call that shorter leg? If this whole side is S, what's this side going to be? It's half of S, so I'm going to call it S over 2. Then, what would I have to multiply it by to get the height? Root 3. Short leg times root 3 gives you the height here. So that height is going to be S over 2 times the square root of 3. Or I could write that as square root of 3 over 2S. So I've got 1/2 S times square root of 3 over 2S. And I can put those together and I will get square root of 3 over 4 times S squared. Now everything's in terms of S, right? So, now, you can do this every time. My problem is a lot of times I am not great at memorizing formulas. Like, even though I've done this many times, I couldn't exactly remember that. I remembered a 3 and a 4, but I think I would have left off. I think I would have done 3/4 s squared if I was trying to do this from memory. But this is going to be the same every time you have an equilateral triangle. So you can, in your mind now, memorize that square root of 3 over 4s squared. This is the formula you're going to use for equilateral triangle. Right, so if you see cross sections perpendicular to the x-axis or equilateral triangles, here's your formula that you're going to use. I tried to walk you through it one time so you know where it comes from, so that if you forget it, maybe you could work back and do that. But if you just memorize this, then you wouldn't have to do all that work. And they would not expect you to show work, even if it's free response. So that gets our area formula. Now let's look at this specific situation. Okay, so this is for any equilateral triangle. For this specific situation, we've got let's see, we're running short on time. Let's just graph this on the calculator. It's 2 lines, but
Is it like two like straight lines and then we put the bases like the
I think it's really just 1 minus 1/2 x and negative 1 plus 1/2 x. So, and then we also have the line x equals 0. Which line is x equals 0? Not across. It's your y-axis. Y-axis here. So we are looking at, I'm going to sketch it really quickly here. What we're looking at is we've got this line right here, this line right here, and then the x-axis. So we are looking at this area. I'm sorry, not x-axis, y-axis. We're looking at this area here. So it's on this picture, it's just this little piece right here. I probably could have graphed that by hand just as quick. Because this is 1 minus 1/2 x, right? The 1 minus x over 2 is 1 minus 1/2 x. And this is negative 1 plus 1/2 x that we're looking at here. So what would s be for this function? So that's the length of this side that we're going to have here. Okay, top minus bottom. So that's 1 minus 1/2 x minus negative 1 plus 1/2 x. All right, which will be, let's simplify some before we put it into the other equation. We'll distribute this negative here, which will make that positive and make this a negative. So we'll get 2 minus x, because we'll have a negative 1/2 and negative 1/2. This will give us a negative 1. So that's our s right there, 2 minus x. So our area formula then, we did all that work for that area formula. So now we just can do square root of 3 over 4 times 2 minus x squared. And then the last part is integrating that. Again, this square root of 3 over 4, it is a coefficient. So I can put it on the inside, or if I wanted to, I could put it on the outside of my integral. It doesn't matter. So you may see that in either place. What are my limits on my integral? 0 to 2. They come from the x-axis here. So if we integrate that on the calculator, and again, this is one that could be done by hand pretty easily, but I forgot to multiply it by square root of 3 over 2. So square root of 3 over 4 times 8 thirds is going to be, let's see, that would reduce 2 root 3 over 3.
That's on pi. No, it's not.
No, no pi for this one because the pi on the last one came from the semicircle.
Yeah, I was saying it could have been a radian, but there's 3 on the bottom.
Right, right. Okay. All right, we really need to look at this last one because of this isosceles triangles with the hypotenuse as the base. Oh, wait. I don't like isosceles triangle with the hypotenuse as the base. Well, all right, I'm going to change this one for today. Isosceles triangles with the leg as the base. That makes this one a lot easier, actually. All right, so we've got a circle. What's the radius of this circle?
3 over 4. What was it?
X squared plus y squared equals 4.
Yeah,
Its radius is going to be 2.
that didn't have to do with
This is our base. That comes from this equation right here. All right. Our cross sections are perpendicular to the x-axis. So what we're going to be doing is we're going to be building isosceles right triangles that have a leg in the base. So if we're thinking about this isosceles right triangle, this right here is S. The length of this side right here would also be S, because if they're isosceles, that means their two legs are the same. So what would the area of that triangle be? 1/2 S squared. 1/2 base times height. So this one's not an equilateral. So the base and the height are the two sides perpendicular to each other, which in this case are both S. So your equation is much easier if that leg is in the base. It makes it, if the hypotenuse is the base, it makes it harder. That's why I changed it. All right, so we need to know S. We don't have S. So I got to do top minus bottom, but I only have one equation. Is this a dy or a dx problem? Dx. So I'm going to solve this equation for y. X squared plus y squared equals 4. So if I subtract my x squared, I will get y squared equals 4 minus x squared. I will square root both sides of that. And so y will equal plus or minus the square root of 4 minus x squared. So what happens with this, that plus or minus makes this two equations. The y equals positive square root of 4 minus x squared. That's the top half of this circle. And then, I'll use purple for this other one. Y equals negative square root of 4 minus x squared. That's the bottom half of this circle. So if I'm trying to find S, I can do top half, which is 4 minus square root of 4 minus x squared, minus the bottom half, which is negative square root of 4 minus x squared. And you will get 2 root 4 minus x squared. So that's your S. You're doing top minus bottom. I mean, if you recognize that's what's going to happen, that's fine. But if you did plus and then you had a negative here, it wouldn't give you. It'd cancel out and give you 0. So here we're going to have our area formula. It's going to be 1/2 times 2 root 4 minus x squared squared, which you could leave like this or you can simplify 1/2. That's going to be 4 times 4 minus x squared when you square that square root. So you get 2 times 4 minus x squared there. So, I know the bell's rang. 8 minus 2x squared. So we got to integrate that from -2 to 2 dx. Because you're doing the entire x-axis there. And I'm not going to solve that on the calculator because the bell has already rang, but you would type that in. All right, so the homework for tonight, I think we've covered enough for you to do it, hopefully, or at least have somewhere to start from it. Finish those last 3 from the worksheet that you guys have. See ya.